Welcome. My name's Michael. I'm a software developer, as you probably guessed. I run a little consultancy firm. I'm here today to talk about FSharp from the point of view of what I've called the curly brace developer. So I'd quite like a show of hands at this point, but I'm kind of assuming A, most of you have not seen FSharp before, or else I'm not quite sure why you're here. B, can you put your hand up if you know either Java, C# or C at some, yes, awesome. You are the audience I was expecting. This is always good. So yeah, as I said, I run this little consultancy firm. I'm currently working on a product called Kritu, a little Swedish accountancy firm, which will not be Swedish for much longer in the sense that we're building out sort of international clients at the moment. The reason I mention this is because I often get asked, sort of after doing these sessions, about sort of cross-platform FSharp and is it really open source and can you really run it on Linux and all the rest of it. Yes, we're running a production stack on Linux and it's working fine, and we're loving it, basically. So FSharp as a programming language, it's one of the Visual Studio sort of, or the visual, I suppose they should be called, set of languages published by Microsoft originally. But it is open source. It's now sort of been mostly handed over to the FSharp Foundation, so fsharp.org if you want to know more about it. So basically, Microsoft is still doing sort of QA and running the build servers and all that kind of thing, but the actual sort of management of the language is being handled by the FSharp Foundation. And that means that it's kind of got a bit of a head start on most of the other .NET languages in terms of sort of the cross-platform story and some of those other bits and pieces. So there's quite a lot of interesting stuff already going on. And yeah, today there's really nice instructions on the fsharp.org website for getting you up and running, different editors, different operating systems, sort of different coding environments. I'm not going to go through any of that bit. I'm just going to have a look at the actual language. And the way I'm going to go about it is just taking a simple program written in C#, which hopefully will look fairly familiar to those of you who know Java and C. And then we're just going to go through a step-by-step process, first of doing a direct kind of like-for-like translation into the FSharp syntax, because FSharp is kind of a fairly multi-paradigm language. It's fairly flexible. You can do that. And then we'll kind of try and see whether we've got time to take that a bit further in terms of not just a direct one-to-one translation, but how would you go about writing that same type of program in FSharp in a sort of more idiomatic kind of way. So let's have a look and see how things go. So what I've done, I'll have a link to the GitHub repository at the end of this, but what I've done basically, I've just set up a Visual Studio solution. I'm not actually using it in Visual Studio because it's a pain for presenting with two projects. So there's sender C# and sender FSharp. Sender C#, as you might expect, is a fairly normal C# type program. And I'm just going to walk through this code quickly first. So this is valid C#. Apart from the fact I've sort of lumped everything into one file to make it easier to present, I'm kind of hoping it will vaguely resemble the way that you would write actual real sort of production C# code, which means it's slightly overcomplicated for what it does, but there's a few features I wanted to include. And it is just a really, really simple program. What it does is it loads up a CSV file with a row of email addresses and messages. Let's just have a quick look. So there's our CSV file, and then it pretends to send an email to each of these people, but obviously in this environment it actually doesn't. It just it'll just write something to the console. So let's have a quick look. So this hopefully will look familiar to everyone. So you've got your using statements. That's sort of loading up references and things. We're relying on an external package here. I'm not going to go into sort of package management. The story for that in FSharp is sort of the same as the other .NET languages. So it's lovely. We've got our namespace. And then we start getting into our code. So we've got a class that represents a row in our CSV table. And so we've got our name and an address and our message. And we would like to deal with the fact that we may get duplicate data, which we often do in these kind of situations. So we'd like to have value equality on this class. We'd like to compare, if the data within the class is the same, we want it to be equal rather than doing a sort of reference equality. So there's a bit of boilerplate. I'm not going to go into too much detail. There's a nice little MSDN thing you can look up there if you want to. But we need to sort of make sure that we override our equals and the other equals method. and the get hash code implementation, and the equal operator, and the not equal operator. Has anyone had to do that before? .NET? Look familiar? Some people are nodding. So there you go. So we've got our class to store our rows from the CSV thing, the CSV file. I actually quite like this little CSV library that I picked up. It's the first time I'd used it. But what you can then do is you can provide a nice little mapping layer. If you are lucky enough to get a CSV file where the column names exactly match your property names on your object, you don't even have to provide a map. But in this case, we've got our email address with a space in, which obviously you can't have as a valid CSharp property name. So we needed a little mapping class. And then obviously one of the things you want to be doing in your object-oriented code is it's nice to do things via interfaces so that you can do things like dependency injection, so you can swap things out for testing, all those other nice little lovely things. And sort of following sort of nice little solid principles, single responsibility, it's nice to have quite granular interfaces. So here we've got our email sender interface, which sort of takes those three strings and will be responsible for sending an email. We have an implementation of it which just writes to the console if an email address is there. And if there is no email address, it fails and says, oh, I failed. And then we've also got a CSV processor interface, which again just, takes a list of CSV rows to process and processes them. And then, as you might expect, our implementation of that interface takes the email sender as a dependency that can be injected. And we send off the emails, and we just have a nice little counter there. I can get rid of that stray white space. We have a nice little counter there that just counts each time an email is successfully sent, return the count, and then our famous static main function that just plums everything together. So in your real application, that might be dependency injection. It might be sort of whatever mechanism you're using to do that. And that just opens up the CSV file, reads it all in, sends the email out. I'm hoping this piece of code as it stands, at least at some level, makes sense to everyone in the room. Is that kind of good? Is this some nods? I'm hoping the rest of you are shy rather than lost, but let's carry on in hope. So let's grab all of that, because we also have our FSharp project, which doesn't do anything at the moment. So this is an FSharp file, .fs file. It's in an FSharp project. At the moment, it has the classic Hello World program. So you'll notice a few things that we can spot immediately just from this before we get into the rest of the conversions. So one is that if you only have one source file in your project, FSharp doesn't actually require a namespace of any kind. It will just run the code in that source file. It also doesn't require a main function. You can specify one with a sort of entry point attribute, but if you don't and you just have code sort of in your last source file, it will just run it. So this is a complete program. This will compile and it will run and it will print hello world. Other thing to notice here is that when you call the printfn function, which is a function, we don't have any brackets. We just put the hello world string afterwards with a space. And that's how calling functions is done in FSharp generally. So you don't normally have kind of the brackets with lots of commas unless you're calling another .NET language's function from FSharp, which we will show in a moment as well. And if you have more arguments, so if we change that to say, so the FSharp compiler will actually look at print strings and look for places where you want to substitute values in. So that's a function that takes 2 arguments now, and you just put spaces in between and you just keep on adding arguments. Another thing which it's good to get out of the way nice and early is that white space is significant in FSharp. So for those of you who haven't used white space significant languages before, basically if you do this, that's broken. You have the printfn function on one line. If you do this and you indent the line below, then it assumes that because this line is indented from the line above it, that you want to have it as part of the same context, and therefore it will actually apply those arguments to the function on the line above. And you also do that for things like declaring function scope and those kind of things, which we'll see in a moment. So let's grab our CSharp code, and let's paste it into the FSharp buffer. And as you can see, quite a few things go red straight away, but let's work our way through and sort of get rid of the compiler errors as we go. So can you see the messages at the bottom? Can everyone read those? Because they'll be quite helpful as we go along. Excellent. So the first thing it's telling us is that you can only have compiler directives prior to the first namespace. So it wants the namespace first. Well, that's easy enough to deal with if we have a namespace. And in fact, you've got a choice in FSharp. I'm not going to go into the details here, but you can either have namespaces or modules. I'm actually going to make this a module because it's going to have some static methods in, and it's just a bit nicer. And yeah, we have an error-free first line. We also had some curly braces denoting our namespace. We don't need those anymore. We're in a white space kind of sensitive context, so as long as we don't indent everything, it will assume that it's in the module context. Does that kind of make sense? So the module is the overall context for this file. If anything starts on the far left of the screen, it's in the context of the module. So we can get rid of that. Something like that will do the job. Let's push the rest of that back over. Okay. So it doesn't like our using statements either. It's actually saying that using is a function, which is how you actually deal with iDisposables resources in FSharp. So that's not what we want here. We want import statements. So let's we can change our using to opens, and we give it a moment to think about that. Likes that more. And actually, it turns out that these semicolons are optional, so let's just get rid of those because it's a bit cleaner. Okay, so nothing that exciting now. We have a module. We're importing our dependencies. This is looking good. I'm not going to type all of this by hand because that would take forever. So we've got some things that we can cheat with a bit. So we've got our CSV row here. So this is just a class which we want to have value equality. We don't really want to have any behavior. It's just purely a piece of data. And this comes up often enough in programming that FSharp actually has a type specifically for this job. So you do actually get some curly braces in FSharp. This is one place. There's another place that you get them as well. But the curly braces here are a way of defining a type that has value equality and by default is immutable. And that's why I've had to specify for each of these fields that it is mutable, because the CSV library that I'm using, which was written in CSharp, assumes that it can change the values of those fields as it loads the data from the CSV file. So I'm sort of overriding the default there and saying that we want that to be mutable. So that, as a record type, because it's got those curly braces, that will do all of the sort of equality stuff for us, and the compiler will deal with all those bits. So let's get rid of that one. So that's quite nice, but what about our row map? Our row map thing here, that isn't sort of just a data holder. That's actually a class, and as you can see, basically, it's almost just a wrapper for calling that map method in the constructor. So we don't want a record for that. We need an actual class for that one. So what does an actual class look like in FSharp? It looks something like this. So this is where the white space, the significant white space, starts coming into its own. So we've got a few things going on here. One is we've got these brackets here. That's just a way of saying that this is a class and it has a default constructor that takes no arguments. So that would be the same as having your default constructor in your class in C#, our public constructor down here. We're saying that we inherit from the CSV class map. That's where sort of this mapping thing is coming from. And there's a couple of things going on. One is that if you inherit from a base class, it's automatically assigned the name base within the context of the class that's inheriting from it. And the other thing to be aware of is that putting base there is actually compulsory. FSharp will not allow you to implicitly call methods on the base class. You actually have to specify that you're doing that. And this do here is just a way of saying that this context is going to be sort of executed as a block as soon as the constructor is called. So that effectively is the code in the default constructor. And if we go down here, you can see that it matches up fairly closely. We also have our little lambda expressions. So here the code is a bit longer than C#. So lambda expressions in FSharp start with the fun keyword. Then you have your arguments. Then you have the arrow. And then you have the body. Like with C#, if you've got a single expression on the right, well, FSharp, everything always has implicit returns. So it will return the value sort of on the right there. One thing we're doing then is we're using this little arrow operator. And this is basically a way of saying, take the result of everything on the left and pass it as an argument to the thing that's on the right. Does that make sense? So here we're taking m.name, where m is a CSV row file, and we're sending it to this box function. Why are we doing that? Well, it turns out that map here, again, I don't know if you can see this, map in C# has been defined as a function of CSV row to obj, which means in C# you could return anything you liked, and it would go, hey, that's a subclass of obj, I'll just cast it, and we're golden. FSharp, by default, well, FSharp doesn't like doing implicit casts. It will rarely do implicit casts. So here, we actually have to send to this box function, which takes any value of any type and turns it into an object. Okay? So you actually have to tell the compiler, yes, I do know what I'm doing here. I did actually mean to send this an obj. The other thing which looks a bit weird is we've got this ignore thing on the end. The reason we have that is because everything in FSharp is an expression. So it will evaluate and it will return a value. Even things like if statements or for loops are expressions and they will return a value. If that value is anything apart from the equivalent of void, which is called unit in FSharp, you will actually get a compiler warning saying you've called something here. Let's actually get rid of that. You've called something here. It's returning a value. You're not doing anything with it. Did you mean to actually do that? It says. Should give me a warning in a while. Yes, there we go. So this expression should have type unit, but it actually has type of property map because that's actually a Fluent API. The reason it warns you of that is because FSharp, although it will allow you to write code like this, which is object-oriented and relies on having side effects on sort of data, shared data, it kind of assumes that you're probably writing functional code, which with pure functions. And obviously, if you have a pure function, so that's a function which for any one input will always return the same output, so it doesn't rely on sort of any external state at all. If that pure function is returning a value and you ignore it and you're not doing anything with that value, then you're just wasting time. Because the only way that that pure function can affect anything else is by passing that value on to something else. So the FSharp compiler actually, it doesn't force you. You can compile, and it will compile and run, but you'll get warnings every time you return a value that you don't explicitly ignore. I've hidden my clock. That's not ideal. So let's have a quick look. We want an interface here. So interfaces look very similar. The only slight annoyance of FSharp here, this is one of the things where C# actually gets it better, is you can't actually supply names of parameters for interface methods, which is a rather bizarre limitation, but there you go. This little asterisk format here, because I wanted to stay compatible with the C#, that's actually a way of defining what's referred to as a tuple. If you may have come across them in other programming languages, it's just a very thin wrapper object around a sort of ordered set of items. So here I'm saying that I take a single argument of 3 strings, and there I can use the sort of normal C# comma delimitation. And then we can, ooh, went a bit further than I expected. That's messed up a bit. And then we can actually implement our interface. So again, we can make use of existing sort of code from the .NET infrastructure, even code that's written in a way that you wouldn't necessarily normally write it in FSharp. So all of that functionality is there. We can implement the interface, has the send method, and a couple of print statements instead of console.writeLine. But effectively, we're talking about hopefully code that looks quite similar. You've got the if statement in there, and again you can see the then at the end, and again you can see the white space, significance of white space there. We're saying that the 2 parts of the if statement are defined by the fact that they are indented like this. Returns are implicit, so this function will either return false if it ends up there, or true if it ends up there. There's no sort of need for a return keyword on that one. And we can do something very similar for the other interfaces. So let's just whack those in. Done that correctly? So for the CSV processor, this is the first one where I'm actually going to start having a look at how you might write things a bit differently if you were actually writing this code in FSharp to begin with. So in our... Sorry, just a minute, let me sort out why it doesn't like that first. So in our implementation, our original C# implementation, we've got this for each loop here. And we're going through the rows, and we're calling distinct on them because we don't want to send duplicate data. So that's why we needed to put in our equality check so that, in this case, link can strip out duplicates. And we're going through, and we're trying to send our message. And if we succeed, we're incrementing the counter. And if not, we're just ignoring that bool. And then at the end, we're returning the count. And we've got that mutable integer count thing up there. And this works fine, but it gets quite wordy in FSharp, because FSharp assumes that everything is immutable, so you end up with sort of lots of mutable keywords and things. And the other thing is that one of the advantages of working in FSharp is it's supposed to be nice for writing nice functional code, and you can sort of get pure functions, and you can do things in parallel, and you can do all these other nice little bits and pieces. So I thought, well, let's start here having a look at how we could do this a bit differently. So what we've got in here is we've got our class, and its constructor takes the email sender, exactly the same as the other one. So it takes that email sender interface. We've got a private internal method here called row to email. And this is a method that knows how to take a row from the CSV file, and it knows how to extract the information it needs and send it to the email sender.send method. So if we hover over that, we have a row to email method, and it's a method of a CSV row to a Boolean, because that's what our email send method returns, depending on whether it succeeds or fails. As an aside, we can just use the email sender that was passed in the constructor. We don't have to sort of set up a private field and assign it to it in our constructor and then kind of use this to call it. And then we implement our interface. And this is where things probably start looking a bit stranger if you've not used FSharp before. So process, it's still a function which takes the sequence of CSV rows. or that's an alias for IEnumerable. It's just any kind of iterable collection of CSV rows, and it returns an int. So it's still doing the same thing. We're still counting how many emails we managed to send through. So we're taking those rows, and we're using our pipe operator. So if you remember, this takes the thing on the left, and it stuffs it into the function on the right. So we're taking our rows, and we stuff them into the seek.distinct method. So that strips out our duplicate data. But it also returns, takes the sequence, and it returns a sequence. So we still have a sequence coming through our pipeline. OK, so fine. So we now have map. So for those of you who've used link, that's actually the same as select from the link library. So we have our map, which takes 2 arguments. So map takes a mapping function, and it takes a source sequence, and it returns another sequence. So this is not pure functional code as such, because here we're actually creating a side effect, which you can in FSharp. It doesn't stop you from doing that. But our row to email method is actually sending our emails and then returning a bool depending on whether they send successfully or not. So that's a function of CSV row to bool. So now we've done the mapping. So now instead of having a sequence of CSV rows, we have a sequence of booleans. Making sense? Are we going through the pipeline? So our first CSV row comes in. It's the first one, so it's obviously distinct, so it gets passed on. It gets sent, and it either succeeds or fails. So we've now got a Boolean. The Boolean then gets passed into filter. Filter again takes a function as its first argument. So it takes a predicate. In this case, there's actually a built-in function in FSharp called ID, which is the identity function. It just returns whatever you pass into it, because we've already got a bool. We don't need to kind of do any checking here. So we filter out anything which returned false in the row to email thing, and then we just take the length of the sequence, the length of the things that are left at the end. That kind of makes sense to people? So you've kind of got this ongoing pipeline. And the nice thing about that is because as long as our email sender is thread safe, we can, for example, there is a library called pseek, which does parallel sequencing here, and we could just stuff it in instead of map, and we would immediately parallelize all of our email sending, and that's fine, and that's safe, because we're not sharing any kind of mutable data. And our main function is just as unexciting as it used to be. Create an email sender, create the processor using the sender, set up our configuration for our CSV file. There we go. Now, this is all lovely, and I wanted to start with this because it gives you some idea of how you can use the libraries that you're already familiar with, and you can write the sort of code you're already familiar with in FSharp, if, in my mind, slightly more concisely, but that's kind of a preference thing. But obviously, that's not much of a value add over using the languages you already know. So let's start playing with a couple of other features and see how far through we can get in the time available, because I'm bound to run out. And start having a look at things that you can't do easily in other languages. So one of the ones that I'm quite fond of, which is quite fun to play with, is you can effectively actually create compiler plugins for FSharp via a mechanism called type providers. And as the name suggests, these allow you to create types at compile time from data which isn't your code. So let's have a quick play with a type provider. So I've already installed the package. So we've got FSharp data. And we're going to create a type here. And we're going to feed it an example CSV file. So now we have an example CSV file. It's actually loaded that from disk in the background. The compiler has actually gone off, found that file, read it in, parsed it, and it's made a good guess as to what data it thinks is available. So it's created this type under the hood, which is a sample emails.csv.row. So let's see if we can use that. Let's get rid of we don't need our map or our CSV row type anymore. Let's get rid of those. Send doesn't change. Okay, but here we need to use the type that's been created by the type provider. Let's do that, wait. And email address is still in red. Let's have a look. Oops. What has happened there? More like it. What's going on there? Well, it turns out in FSharp that you have this mechanism for if you want to have a identifier which wouldn't otherwise be legal in the language, you can wrap it in double backticks and use it anyway as an identifier, which is quite nice when you're doing this kind of data access. So here we are actually using the row names from the CSV file. What's also slightly interesting about this one is that if we get a new CSV file and we drop it into our code repository and we recompile and it has different columns with different names, this won't compile anymore. So it is actually generating the types on the fly from the example data that's being given to it. So we can get rid of the config, we can get rid of the provider. So now, instead of newing up a CSV reader, we can load. Here we're loading the same file, but obviously in reality you wouldn't be doing that. You'd have some example data to generate your types, and then you would load whatever it is that you're actually wanting to process. And we can get our rows from here. And that should, at this point, all work. So that's one nice thing. And I think we've got a few minutes left. Yep, let's go. So the other thing which comes up a lot in FSharp and is really very useful is we also have this idea of union types. So let's try and add some type safety to this code. At the moment, it's kind of very loose and woolly. You know, here we've got a send method that takes 3 strings. We don't really know what they are. We've got a return method, which is a bool that doesn't really give us very much information. So let's start adding a few things in. So let's have an email info record here, where we'll have whatever it was, name, email address, and message. Nothing too exciting there. But what about our return type? You know, we've got these 2 distinct things that we can return. And, you know, we get this sort of classic thing that we end up either passing in an out parameter to kind of work out what's happened with things like try-parse, or, you know, a mutable object in that then gets mutated and we check what the return is. FSharp gives us something that's called a discriminated union, where you can actually specify that there are 2 distinct cases. So we can say success of so we can do something like that. So our email send result now is a class that can contain either a success or a failure. Does that make sense? So it can be one or the other, but it can't be both, and it can't contain fields from both. And there's no reason that the data in each needs to be the same. They just both happen to be strings here, but they could be anything. They could be other types. They could be pretty much whatever you want. So let's change send to go from email info to email result, send result. That will break this, obviously. And here we can't return false anymore, because that doesn't match our interface. So we'll return a failure. And here, oops. we'll return those. And obviously, we'll return, I think it was the email address we said, didn't we? What have I got wrong there? Name, email address, message. Oh, that should be subject, shouldn't it? Are they the wrong way around? Oh, no, that's fine, because we've got 3 strings we need to splice in, and there's the subject and the message. So immediately we can start passing quite a lot more information back and forth. But there's something else that we can spot here as well, which is that actually, at this point, because we've done our single responsibility nicely, and our interface has a single responsibility, and only has one abstract method, which tends to be what happens if you sort of do single responsibility properly. It also now has a rather distinctive type signature. You know, it's an email info to email send result. So there is an extent to which we don't really need this interface at all. We can just take a function with that signature. You know, the interface is purely a way of saying that that's the type of function that we want. So we can take that out as well. And we can start changing things here to be a bit nicer as well. And we can actually start getting a bit more information out. So send now wants one of these record types. Well, I don't have very much time left. So what was it? Email address. So email address equals row dot email address. Subject equals subject. And message equals row dot. Doesn't like that. Our email sender is not defined. Yes, that's a good point. And now we're starting to get some type inference kicking in, where because this email sender is being passed in as an argument, it's actually inferring the type it has to have. It thinks it still needs to return bool because it's being used in filter here. So just for a moment, let's show how you actually deal with these things when they come in. So we'll drop a lambda function in here. So this is our result. And what we can do is, because our result is one of these union types, we can match against the possible things it can be. We can throw away here the fact that it's a success, because we don't really care about that. What the value of this success is, all we care about is whether it is a success or not. And we can do this match thing here. And you will actually get a compiler warning here if you only match some of the cases. So you get a nice bit of type safety here that if you only deal with the success path, it will tell you in a warning you're not dealing with failures. And also this is generally how things which would in other languages be sort of nullable types that could have a null value are dealt with in CSharp. They tend to be assigned something called to an option type, which can either have some value or none. And if you get passed back an option type, you know that you have to check whether you've got the value or not. And then once you've checked once, you can just return the value that was wrapped in it, and you know that it can't be null, and you tend to get rid of quite a few null reference exceptions. So I wanted to go through that as sort of a quick translation, a few features that you might not have come across before. I'm aware that there are also some others, so I will wrap up at this point. So if you want to have a look at this code, there is this GitHub repository. So it's got both the CSharp and the fully translated FSharp code, so you can have a look at that. I'll leave that up in a moment. If you want to hear about some of the other features that FSharp has, which I haven't talked about, so it has a couple of other weird and wonderful features. There is a short 15-minute video on my blog. Again, we'll post the links up later. that talks about some of the other unusual features which exist in FSharp and don't in most other languages. And yeah, I hope that just gives you kind of a bit of a feel of how, on the one hand, you are still working in sort of a wider landscape of sort of the .NET infrastructure, so there'll be lots of libraries that look familiar, lots of sort of bits you can pick up on that have existed for years. But on the other hand, it is actually a different language. It does allow you to do different things. It allows you to express some things much more easily, and other things not so much. Yeah, I hope that encourages you to give it a try and see that, yeah, it's not quite as alien as it looks, but it is worth having a look at. Thank you very much. Yes, I can be around for questions for a few minutes. So I don't know if... Yep, okay. I'll... No, lower and uppercase. It's because FSharp is based on OCaml, which is an older programming language. And so there are a lot of things from the .NET that have aliases, so that you can use either the OCaml name or the .NET name for them, especially the core types, so kind of the ints, the strings, and generally it tends to be either a capital or a lowercase first letter. It is case sensitive though, for other things. I'll unplug this stuff so that we can set up the next guy, and I'll hang around at the back for a bit if people want to ask other bits.